Hello, I'm Raj Chengappa of India Today, and today we have a very special guest, Ashwini Vaishnaw, who is a minister, union minister for three important ministries, Ministry of Railways, Information Broadcasting, and Electronics and Information Technology. But today we will be focusing on the third hat that you wear, which is as important, Information and Electronics Technology, and looking particularly at semiconductor chips. That is now the heartbeat of the electronic industry, drives all our cell phones, laptops, cars, name it. Everything has to have a chip that drives it at the moment, and therefore very, very critical. I'm coming to a fundamental question. That is, in 1984, India seemed like ahead of this semiconductor chip race. It set up a laboratory called the Semiconductor Laboratory in Chandigarh. 40 years later, we seem to have missed the bus. We are now importing 95% of our chips. What went wrong from this particular thing that we started, which we should have been the leaders, but we are the laggards?
Thank you, Raj, for having me on India Today. It's very important that we understand the importance of semiconductor industry. You gave the examples of mobile phones, electronic items. Today, semiconductor chips are used in practically everything that uses electricity, whether it is a refrigerator at home, whether it is the television set, whether it is the scooty which uses battery and the engine is controlled by chips, whether it is a small car, big car, whether it is a train, aeroplane, practically everything in our life today has chips which control the electronic circuits. So it's very, very important to understand how this foundational industry works. When I say foundational industry, the word is synonym to the industries like steel industry, chemical industry, plastic industry. There are so many industries where if you have the basic foundation in your country, then you can build upon that foundation and create many other industries. For example, if you have the steel industry, then you can have steel fabrication, you can have manufacturing of machines, you can have construction of bridges, you can have construction of buildings. It's a very, very important industry, right? That is the nature of this industry. This is a very complex industry, significantly more complex than any other manufacturing activity that you would have ever seen. This complexity means that only a very few countries and a very few companies can really get into this.
Right. It's a bit like space and atomic energy, where you have an exclusive club that is there.
Very good analogy you have given. It's like space and atomic energy, where the talent required, the skills required, the knowledge required is very deep.
Right.
Very deep. And it has to continuously evolve.
Right.
It cannot stay stagnant. It has to continuously evolve.
So, can I come to the primary question that I asked? Because the Prime Minister mentioned this on Independence Day. He said, we set up this chip plant in 1984, and we didn't seem to have...
No, so there's history even behind that, but I don't want to get into political discussion here. Fact is that in 1960s, Fairchild wanted to come and set up a plant here, then Intel wanted to come and set up their plant.
Interesting.
It has been from 60 to present time, 60 to 2014, practically it has been a period of missed opportunities, but let's not get into that. What's important is, as our Prime Minister said, now we must be drivers of this bus.
Right.
We should not be looking at the bus that we have missed. Forget the political setup of those times, that era. What's important is today our Prime Minister has a very clear vision, clear focus, laser-sharp focus on execution to make sure that the semiconductor industry gets developed in our country.
Let's turn the question the other way. There were lessons that you have learned from those particular experience we had for 40 years. Let us now look at the Indian semiconductor mission that you launched in, I think, January 22, announced in December 2021, if I remember.
Correct.
Right? So how different is the approach of this particular mission? Because we did have a mission in 2007 also, that the Modi government initiated. How different is it from what was happened in the past, and what were the lessons you learned and incorporated and made sure it wouldn't happen in this?
What's important is we understand the nature of this industry. This industry works very well when the entire ecosystem gets developed. There are more than 500 chemicals which are used in manufacturing chips, right? There are more than 50 gases, and these are chemicals and gases where you measure purity not in parts per million, but in parts per billion and parts per trillion.
Right.
These are ultra pure materials.
Right.
For getting ultra pure materials, for getting that entire stability of the grid, getting that stability of the entire foundation, all those things are extremely important. One has to work very diligently to make sure that the entire ecosystem gets developed and the foundation of this industry gets laid properly so that the industry can have a run for next 20, 30 years, 40 years. And we have to look at the entire value chain. The value chain starts with design.
Right.
Comes to fabrication.
Correct.
Then comes ATMP, which is assembly, testing, marking and packaging.
Right.
Then comes the modules.
Right.
The modules go into the finished product.
Right.
This is the, if you look at the value chain. This value chain is supported by next layer of all the chemicals and gases. Then the value chain is supported by a series of EDA tools, other consumables, all other items which go into this. The equipment which goes into manufacturing. Then comes the ultra pure materials which are used for manufacturing chips.
Right.
So this is the complete ecosystem that needs to be built. You can't build just with a fab or setting up one unit. You have to look at the entire thing.
So how did the semiconductor mission that you've launched actually take care of all these processes, the ecosystem that you talk about?
We have worked diligently with every ecosystem player.
Right.
Very diligently we have worked with chemical gases, with the equipment manufacturers, with the consumables, with the material suppliers, material manufacturers, with the state governments, with the local level panchayat and municipal governments. We have really worked very diligently with the industry to come up to this stage today.
Right.
And
when you say this stage, what is the stage we are at today in this journey? It's now 3 years since you launched it. What is the stage which we?
This is an industry which requires a minimum of 10 years to get established.
Right.
That's the experience everywhere in the world. China took, I think, about 20 plus years. Japan began way back after the Second World War, and US it started somewhere during the Second World War and immediately after that. So this really takes some significant time and effort to build up. So today we are at a stage where 10 units are under construction or under planning. The first unit which has started pilot production, and we have the pilot production chips in this entire thing. You can see the pilot line chip. This is CG semi line, which is the pilot line. Keynes pilot production will start very soon in next few days.
The first one is from Micro.
This is from CG semi.
Yeah.
This is from Keynes, and this is from Micron.
Right.
Again, they are going to start the production in around December, January.
So in that value chain that you talked of, the ecosystem, these companies fit in where in it? You started with the fact that you have to do the fab and the ground level. Where do you set up industries in
this value chain? Design, we all know that we have a very good strength.
Which is indigenous.
Yes, our people.
Right.
A lot of companies working here.
Right. The GCCs.
The GCCs, and recently we inaugurated one facility of ARM, which will be designing the most advanced 2 nanometer chips.
Wow, which is like the cutting edge.
The cutting edge. Right. So that's really satisfying that. And again, the entire end-to-end design is going to happen.
So that's one big component.
Then many startups are already supported under the design-linked incentive that we have.
Right.
They are coming up to speed. They are getting VC funding. Their products are getting validated. So the design piece is in good shape.
Right.
Fab, we have selected one fab, Tata fab, which will be set up in Dholera.
Right.
Construction is going on at very good pace. ATMP, we got 8 units.
Right.
We have 2 fabs and 8 ATMP units.
That is the testing.
Assembly testing, and assembly is again a very complex thing. If you look at this, this is the wafer, right?
Right.
A raw wafer would look something like this.
Okay. Right.
And this is of course
this
the
is silicon base, right?
Yeah. Right. Inside is silicon, then there is a cover of other materials which give the strength to the wafer. This is now once the wafer is raw wafer is put into the fab.
Right.
this has to be fabricated. Fabricated means you have to draw the circuit on the wafer.
Wow.
Now imagine if you,
No.
let's take this leaf.
Right.
Let's take this leaf, right?
Right.
This is a small leaf,
Right.
small piece of a leaf. What can you write on this? You can write Raj Chengappa on it.
No, not even that.
Now I ask you to write the entire India Today on this.
Right.
Entire India Today.
Right.
Your
Interesting.
one full copy of it, right?
Right.
Then I ask you to write 10,000 copies of India Today
Right.
ever since it began on
Right.
it
50 years ago.
50 years ago.
Right.
Then I ask you to write all the magazines which are published in India
Right.
on this small piece of
Wow.
leaf, right?
Right.
That's the fineness with which we have to work.
Right.
So that is what nanometers is, right?
To say a nanometer is 1 billionth of a meter, right? That's the unit that we're looking at. So it's even thinner than your hair.
Significantly thinner, 10,000 times thinner.
Right.
Hair
Right.
is 10,000 times thicker than a nanometer.
And on this, you will embed millions of transistors and circuits that are there.
That has to be embedded on this.
Got it. So this is the what do you
This
call
is
the
fabrication.
fabrication.
Now,
Yeah.
once you fabricate on this, you have to take out that small
Right, which fits in.
little thing which is not even visible to naked
Right.
eye. It has to be seen through very, very sophisticated equipment.
Right.
Not even a simple microscope will be able to show you.
Right.
That has to be taken out and given a body.
Right.
So that body has to be given, and like for example, I'll use this very small thing.
Yeah.
This is now a body which is given to a very small little chip inside.
Correct. Almost like a SIM card size.
Yes. But there's a very complex ecosystem built in this now.
Right.
There is a plumbing system,
Right.
there is an electrical system. Many of the chips would be so complex. For example, this chip that you see here,
Right.
this chip that you see here has multiple stories inside, multiple floors like a building complex.
10
It is
story,
a
20 story
10 story,
building.
20 story, 30 story kind of thing.
This is called the GPUs, or this is the
This is a microprocessor, this is
Right.
a controller. Now, so there has to be a plumbing between those stories.
Right.
There has to be a lift which has to take things from up and down. There has to be service lift, passenger
Right.
lift. There has to be electrical connections. There has to be some people living in top floor,
Right.
having different way of working. Some people living in middle floors, different way of
Right.
living. So
It's a mini factory sitting there.
It's a mini city.
City. Let's right. So you have got 8 companies that are
That is
doing
the process of ATMP.
ATMP. Right.
Taking that small
Little
little tiny
thing
thing
and
and,
then-
giving it this.
Right. And
that
then you
module.
have the packaging.
Then the module. This is a module.
Okay, that is the packaging.
No,
that
no. Packaging is making this body.
Okay, that. And then you
So this is as complex as fabrication. Not
Right.
exactly as complex, but a couple of orders different, but very, very complex.
Excellent.
Very, very complex.
So you have now set up.
So 8 units of this,
Right.
2 units of fab.
So you have covered the spectrum of the universe or ecosystem as you
Then
see.
comes the module making.
I see.
Module making is in electronics.
Right.
That is where the electronics comes in.
Right.
Electronics manufacturing comes in.
This is what gets into your laptop or whatever it is.
Correct. This then finally goes into the finished product.
Right. Now you have these big chip makers like TSMC, Nvidia, and the Chinese, of course. Will any of these collaborate with us, or are in talks with them?
One of the big ones, PSMC, is has collaborated with Tata's, and Micron is among the top 5 in the world. So they are also here.
Not looking at Taiwan and bringing their
PSMC is from Taiwan.
from there, but the big guys, no.
They will also come.
They will
Obviously, they will all come.
Now take a
The
look
journey, when the journey begins,
at right.
see, it's very important to understand when you start a totally new industry,
Right.
the world will always look at you with a question mark.
Correct. Yes.
So those question marks are now behind us.
That's
In this Semicon, ASML joined us.
right.
When ASML joined in a large contingent, and
You'll have to describe ASML to us.
ASML is the most complex equipment manufacturer without which no chip can be built.
Right.
It's from Netherlands. It's a company which is today among the most strategic companies in the entire world.
Right.
Between TSMC and ASML, the world cannot function without these two companies. That's the way that's the importance of these two companies. ASML came in full contingent. Their entire top leadership was present here, and they very categorically said that we now believe that India is absolutely on the right track to become a semiconductor nation.
It's a good time to ask you the question is, we are now importing close to 95% of our chips. How do you see in the next 5-10 years, we start now making them indigenously and not cut down on our exports?
Very good question.
Yeah.
If you look at the way we have selected our 10 projects, right? All the 10 projects, if you look at it, we have practically covered every sector. I'll talk about some of the sectors. Memory, which goes into practically everything. Power electronics, which is very crucial to your electric vehicle industry, trains, your large machines, industrial electronics, all that. Then comes the consumer electronics. The display module, which drives every TV and every display, that is part of our program. Silicon carbide, which is a material for the future, that's part of our program. RF, telecom, which are used in radio, radar, all that thing, that is part of our program. So we have practically covered every segment, all the medical electronics which is required, that's also part of the program. So we are practically very methodic, and the entire semiconductor mission is run by professionals.
That's true.
It's run by professionals.
No more
No, it's not
government or public sector that
we have some of the topmost brains working on it. And people like Vinod Dham, who's father of Pentium.
And that's the difference you brought in, I would gather, in this mission that is there.
The mission is run by professionals. And they are the ones who are guiding us in this entire thing. So we are able to today cover practically every segment. So as these facilities start coming online, we will have a significant part of our domestic demand met. But we must also understand that semiconductor is a global industry. It's an industry which is absolutely global. It doesn't know the barriers of country's boundary, and it has to, each material, each component has to pass through multiple boundaries every time it becomes a finished.
And I think that's a very good point, because COVID showed us how important it is for this value chain to exist. And there China was a sticking factor by denial of a lot of these things, and we ran into issues. Given the fact that there's a thaw in our relationships with China, how do you see our collaboration with China on this? Because they're also a world leader on semiconductors. Do you see, firstly, opening out for them, supplying whatever we need, plus collaborations with them on any other front?
We'll see as it goes.
Okay. You're not ruling out any of this, as I can see from what you answered.
We'll see. We'll see as things develop.
Geopolitics, that's the other big thing that's there. America, for instance, has been demanding from Apple to set up their factories over there, and somewhat tells, saying very directly, as President Donald Trump says, not come back here, not in India. How is our reaction to these kind of things when you have a US president wanting to get back all this, make in America, and we are doing make in India?
See, today's world is very different from the past. It's a world full of turbulence. It's a world full of so many different geopolitical changes which are happening. It's very important that we understand what is our role in this world. Our role is to be a trusted partner to the growth story that is visible in our country, making sure that we contribute, based on our strengths, we contribute to the global economy. We will continue to strengthen our position. We will continue to strengthen our industry. Our electronics component manufacturing scheme is now out, and we are expecting 60,000 crore rupees investment in electronics component manufacturing. Many of the units which are coming are going to be at a global scale. We recently inaugurated a plant where the batteries used in mobile phones, they are manufactured there. And it's a very, very large plant. It will be meeting close to the lines which got inaugurated, it will be meeting close to 40% of our battery requirement from one single plant.
So you're saying Apple is not going back? Apple will be here?
Every manufacturer who has come here
will stay.
Is very comfortable here. They are working very diligently. Of course, they have their own policies. I wouldn't like to comment on their policies. From government side, as a nation, we are very clear we must strengthen our base.
Right. If you take a look at the other aspect, and I quickly want to do two areas. One is, of course, the whole business of AI, which is now coming in. You have a artificial intelligence mission. How does this dovetail into that? Because in AI, you need giant processors, GPUs,
absolutely, the chips,
and
high
LLMs.
the high bandwidth memory chips, which will be manufactured by Micron, the processors which are getting developed at IIT and CDAC,
Right.
All those play into the entire AI journey. And I think the way we have consolidated all our forces and properly used the strengths that we have, both the public sector strengths and the private sector strengths, I think that's going to be a good
So
journey.
would we be a player? Because so far we have not been a big player where AI is coming. You have ChatGPT, you've got all the big companies doing it. Where do you see our entry?
See, the world of AI models is evolving.
Right.
If you talk to the experts, they will say that yes, there will be a few very large models, but the big value will come from very small focused models which are focused on solving a problem. For example, yesterday we empaneled 8 new model makers where one of them is focused on material science.
Right. Excellent.
Another one is focused on weather forecasting. Another one is focused on agriculture.
So you're doing the niche things.
Each of these niche will be very important for us because then we can solve some of the population scale problems using these technologies.
2 questions. One is coming back to geopolitics. India has an agreement with US on critical and emerging technologies signed by the previous administration. Do you see the current administration, despite whatever the differences we've had on the tariff front, encourage us, because that was a critical
There
area.
is good collaboration at all levels.
And that you see, that has not been reflected in terms of...
Absolutely, it's going on very well.
But there are also issues of our employment over there with the H-1B visas and the fact, how's that being sorted out?
Yes. No, we are working very diligently with the US government on every aspect of our economy.
And finally, this is the last question I have, is in terms of what we're doing in semiconductor technology, would this be, and that's why the previous question I asked you, would we now be able to drive a lot of jobs into this, and what is the potential on that front?
See, we started this program of talent development.
Right.
We took like in telecom, we had 5G labs set up in 100 universities.
Right.
So that the students basically get the right, absolutely hands-on experience of the technology. Mm-hmm. Similarly, in semiconductors, we have given the latest design tools to 278 universities.
Oh, wow.
And these are latest tools from Cadence, Synopsys, Siemens, some of the most latest tools which are actually used in the industry, the IP cores which are used in the industry. And the result is, in a very short time frame of 2.5 years, students have designed chips. These are the student designed chips. These are the student designed chips.
Based on the equipment.
Based on the design tools that they have access to.
Right.
And we have used the Semiconductor Limited Mohali to tape out these chips.
Oh, okay. Interesting.
To manufacture this chip, fabricate these chips. Now, if you are a startup, right? And you design, you have a great concept, you get the design tools and then you design a chip.
Right.
Until and unless you give a very large order, no manufacturer in Taiwan, South Korea will ever even touch your chip.
Right.
So we have created a concept by which even if somebody wants to manufacture 10 chips,
Right.
we are using the semiconductor laboratory as a platform for giving that opportunity.
Excellent.
And we are modernizing Semiconductor Limited SCL Mohali to increase the production, modernize the technology, and simultaneously use it as a research base for our students. Very few countries in the world can today claim that their students, university and college students, can design and tape out chips.
So this is going to be a huge driver of jobs, you see.
Absolutely. That much in emphasis we have given to talent.
So you're building the knowledge, know-how, and the design capability. Final is, how would you say 5 years from now or 10 years from now, what will India's semiconductor industry look like? What is the vision you have?
It will be a very comprehensive industry. 5 years down the line, we would be manufacturing chips, we would be having a lot of R&D, we would be having great equipment manufacturing ecosystem. We would be having some of the most complex and most required new materials like silicon carbide being manufactured, the material itself being manufactured in India, gallium nitride being manufactured in India. The chemical guys are already setting up their base. They are looking at India as a research and development and manufacturing base. So it's a journey which will become a very significant industry in the coming years.
How would you characterize it? Would you say it become the hub? Would it be cutting edge?
It will be a comprehensive industry. Starting at 28 nanometers was a very, very important decision we took.
Right.
And now once we learn how to make 28 nanometers, then we must move towards the other leading
28 just to explain to our viewers, listeners, 28 nanometers is the fundamental basic thing that drives much of what we do. Am I right?
Close to 60% of the semiconductor market, 60% of this entire market is about 28 nanometers and above.
Right, okay.
So it's a very important, 28 nanometer goes into all your refrigerators, TV, everything practically, every consumer electronics that we use. So it's very, very important, 28 nanometer and above.
So we'll be self-sufficient in that particular aspect?
That chip we start, then we move
to cutting edge.
to 7 nanometers, towards 7 nanometers.
Wow.
And it's a very complex journey. It will require lots and lots of efforts. It's not like any other manufacturing activity, as I explained, the complexity of it.
Well, Ashwini Vaishnaw, thank you very much. I think you've lucidly explained it, given us your vision on where semiconductor is doing, what India has done in these last 5 years or so to really bring us up to speed with what is happening across the world and possibly India becoming a semiconductor hub for the world. Thank you very much for the time you've taken.
Thank you, Raj.
Thank you.
You are watching India Today.